This is the next video in the coordinate geometry set of videos. In particular, this is looking at coordinate geometry, the line worksheet number 10, where this is all about intersection of two lines. Now, unless two lines are parallel, they'll always intersect at exactly one point. And we can figure that out by using two things that we have talked about before. The first thing you can do is you can plot the lines on a coordinate diagram, and then you can just figure out where the points intersect by reading the point from the graph. The second thing you can do is you can solve your simultaneous equations, which you know from the junior cycle and you already know from the algebra chapter we did before Christmas. So I'm going to go through a few examples of doing both. And the first example here says, on the same pair of axes, draw the lines x plus y minus 2 is equal to 0 and 2x minus 3y plus 16 is equal to 0. From your graph, then you need to write down the point of intersection of the two lines. So this is the first way we could get the point of intersection. We could also use simultaneous equations, but they've asked us here to draw the lines on the coordinate plane. So to begin with, we'll take one of the lines and we're going to take x plus y minus 2 is equal to 0. So we need to plot this, and to plot this line, remember we need to find where it crosses the x-axis and where it crosses the y-axis. We're going to start with the x-axis, and when it crosses the x-axis, y is equal to 0. Every time we see a y, we're going to replace it with 0. This then becomes x plus 0 minus 2 is equal to 0. This is going to become x minus 2 is equal to 0. We can add 2 to both sides, and we'll get x is equal to 2. After this then, we're able to write the point. We already know that y is 0, and we've just figured out that x is equal to 2. So now we have the point 2, 0. Then we can find out where it crosses the y-axis. And when it crosses the y-axis, we let x equal to 0. Now we have that x is equal to 0, so up in the equation of the line, we're going to replace the x with 0. What we'll be left with then is 0 plus y minus 2 is equal to 0. Then we'll be left with, again, y minus 2 is equal to 0. We can add 2 to both sides, and we'll be left that y is equal to 2. Again, this point that we'll have is we know that x is equal to 0, and we now know that y is equal to 2. So the point that we have in the end is 0, 2. So then we can draw this line on the coordinate plane. We have 2, 0, and we pop that in, it's going to be here. And we also have 0, 2. Finally then, the last thing we're going to do is draw this line. And I'm going to draw this line in red. When you draw this line, you're just joining the points together and continuing it on. Again, you'll be doing this with your ruler, and you should be really confident at doing this after doing the last worksheet. So you get something like that. It's always good to label it as well. So this line here is x plus y minus 2 is equal to 0. Then we have to draw the other line. I'll do this in blue. So we have 2x minus 3y plus 16 is equal to 0. And first of all, we need to figure out where it crosses the x-axis. When it crosses the x-axis, we know that y is equal to 0. What we're going to do then is every time we see a y in this equation, we're going to replace it with 0. What we're left with then is we'd have 2x minus 3 times 0 plus 16 is equal to 0. This would leave it with 2x plus 16 is equal to 0. We can take 16 from both sides, and we'll be left that 2x is equal to minus 16. And then we can divide both sides by 2, and we'll get that x is equal to minus 8. So the point we have then is that y is 0 and x is minus 8. Then we need to figure out where it's going to cross the y-axis, and I'm going to do that right up here on the top of the page on the left hand side. So what we have is, I'm going to write it out the equation again just to make our lives easier. So we have 2x minus 3y plus 16 is equal to 0. We figured out where it crossed the x-axis. We now need to figure out where it crosses the y-axis, and it's going to cross the y-axis when x is equal to 0. What we're going to do then is we're going to get, every time we see an x in the equation, we're going to replace it with 0. What we're going to have then is we're going to have 2 times 0 minus 3y plus 16 is equal to 0. This becomes minus 3y plus 16 is equal to 0. We can take 16 from both sides. we'll be left with minus 3y is equal to minus 16, and then divide both sides by minus 3. We'll be left that y is equal to 5 1/3. Getting the point then from that, what we're going to be left with is, well, we know that x is equal to 0. We now have that y is equal to 5 1/3. So the point that we're going to have is 0, 5 1/3. Now we have the 2 points, so we have minus 8 and 0, and we have 0 and 5 1/3. So what we're able to do is we're able to plot this. I'm going to plot it in green. So we have minus 8 is 0, which will be here, and we have 0, 5 1/3. So 5 would approximately be here. We need to go 1/3 of the way up towards 6, so I'm going to say it's about here. The final thing we need to do here is join the points together, so we'll get something similar to this. Making sure you're going through each point and out the other side, and that's again labelled. So this line is 2x minus 3y plus 16. Now the very last thing we need to do in this question is it asks us to, from your graph, write down the points of intersection of the two lines. We can now very easily do that. I'm going to put it in blue here. The points where these lines intersect is where I have highlighted in blue, and we can write down that point. That point is minus 2, 4. And that's this question completely done. Question 2 says use simultaneous equations to find the point of intersection of the following lines. So we have 2x plus 3y minus 7 equals to 0, and 5x minus 2y minus 8 is equal to 0. So for simultaneous equations, we put one equation on top of the other. We'll have 2x plus 3y minus 7 is equal to 0, and 5x minus 2y minus 8 is equal to 0. Now, we need to pick the term that we want to eliminate, and I think in this one we're going to pick x. So we need the same number in front of x. So the same number we could make 2 and 5 to be would be 10. So to make 2 10, we're going to multiply by 5, and to make 5 10, we're going to multiply by 2. What we'll be left with then is, well, 5 by 2 is 10, 5 by 3 is 15, and 5 by minus 7 is minus 35. Is equal to 0. 2 by 5 will give us 10, 2 by 2 will give us 4, and 2 by minus 8 will give us minus 16, and that's also equal to 0. Now we have the number in front of x is the exact same, so we have 10 in front of x. However, to eliminate them, we need one sign to be a negative. So what we need to do is we need to multiply one of the lines by minus 1 to change the sign. What we'll be left with is minus 10x minus 15y plus 35 is equal to 0. The second line stays the exact same, so 10x minus 4y minus 16 is equal to 0. Then we can underline and work it out. Minus 10x plus 10x will give us 0x, we don't need to write that. Minus 15y minus 4y is minus 19y, and plus 35 take 16 is going to give us 19. Is equal to 0. Then we can take 19 from both sides to get the y on one side and the number on the other. So we get minus 19y is equal to minus 19. Divide both sides by minus 19 to get what y is by itself. And we'll be left with y is equal to 1. Because we know that y is equal to 1, we're able to figure out what x is. So we take any of the equations that we had at the start. I'm going to take the first one. So 2x plus 3y minus 7 is equal to 0. We know that y is equal to 0, so every time we see a y now, we can replace it with 1. When we do that, we'll be left with 2x plus 3 by 1 minus 7 is equal to 0. This becomes 2x plus 3 by 1 is 3, minus 7 is equal to 0. We'll get 2x, 3 minus 7 is minus 4, is equal to 0. To get the x on the left and the number on the right, we plus 4 to both sides. And we'll be left with 2x is equal to 4. Then we can divide both sides by 2. And we'll get that x is equal to 2. Now, because we have the y value being 1, and we now know that the x value is 2, what we can do is we can figure out what the point of intersection is. and it's just the x value, which is 2, and the y value, which is 1. So that's the point of intersection, and that's the answer to this question. Question 3 says that P is the line x plus 2y minus 4 is equal to 0, and Q is the line 4x minus 5y minus 29 is equal to 0. And it asks us to find P intersection Q, and remembering that that symbol there means intersection. So for this one, because it doesn't tell us, we can do two ways. We could either use the graph method, so graphing the two lines, or use simultaneous equations. I'm going to use simultaneous equations just to recap simultaneous equations and make sure there's no confusion, but if you wanted to use the graphing method, that's perfectly fine too. When solving simultaneous equations, the first thing we do is just write it out. So we have x plus 2y minus 4 is equal to 0, and 4x minus 5y minus 29 is equal to 0. Then we have to decide which term we would like to eliminate. And here I'm going to eliminate x. So I need this number in front of x to be the same. I'm going to have the numbers to be 4, so I need to multiply the top line by 4. What we'll be left with is 4x plus 2 times 4 will give us 8y, and 4 times 4 is 16. Then the second line will stay the same, so 4x minus 5y minus 29 is equal to 0. Now we can see the numbers in front of x are the same, but the signs are different. So what we can do is multiply the top line by minus 1 to get the signs to be different. Then we'll be left with minus 4x minus 8y plus 16 is equal to 0. The bottom line will stay the same, so 4x minus 5y minus 29 is equal to 0. Now, because the numbers in front of x are the same, but the signs are different, we can eliminate the x. So we underline the second line, and then we say minus 4x plus 4x will give us 0. Minus 8y minus 5y will give us minus 13y. And 16 minus 29 will give us minus 13, and that's equal to 0. To get what y is by itself, we need to plus 13 to both sides. And what we'll be left with here is we will be left with minus 13y is equal to 13. Then we can divide both sides by minus 13. And we'll be left with that y is equal to minus 1. Finally then, we need to figure out what x is. So up here, we write one of the equations that we had at the start. So I'm going to write x plus 2y minus 4 is equal to 0. Then we know that y is equal to minus 1. So I'm going to replace y with minus 1 every time I see it. Up here, this turns to x plus 2 times minus 1 minus 4 is equal to 0. We then get x. 2 by minus 1 is minus 2. Minus 4 is equal to 0. Minus 2 minus 4 will give us minus 6, so x minus 6 is equal to 0. To get the x by itself, we put plus 6 to both sides, and we'll be left with x equal to 6. Now, we know from before that y was minus 1. We now know that x is 6, so to get the point of intersection, it's just those two values for x and y, so the point of intersection is 6 minus 1. Question 4 then says m is the line 3x plus y minus 6 is equal to 0, and n is the line x minus 2y plus 5 is equal to 0. It says on the same axis and scale, plot the lines m and n. So I'm going to start here with a. I'm going to start with the line 3x plus y minus 6 is equal to 0. We first of all need to figure out where it crosses the x-axis. When it crosses the x-axis, y is equal to 0. This then will leave the line being 3x plus 0 minus 6 is equal to 0. This will simplify and become 3x minus 6 is equal to 0. We can then plus 6 to both sides, and we'll be left with 3x is equal to 6. We can divide both sides by 3 then, and we'll be left with x is equal to 2. The point we have then is going to be 2, 0. Then we can figure out where it's going to cross the y-axis. When it crosses the y-axis, we know that x is equal to 0. So this will be 3 times 0 plus y minus 6 is equal to 0. This will be 0 plus y minus 6 is equal to 0. So we'll have y minus 6 is equal to 0. Then we can have plus 6 to both sides, and we'll end up that y is equal to 6. Then the point we have from this is 0, 6. Plotting those 2 points, we have 2, 0, so that's going to be right here. And we also have 0, 6, which is going to be here. Then we join those two together, which again you should be doing with your ruler. And when you join it together, you should get something similar to this. Finally then, what we're going to be doing is we get the other line, and the other line is x minus 2y plus 5 is equal to 0. We first of all need to figure out where it crosses the x-axis. When it crosses the x-axis, y is equal to 0. What we'll be left with then is x minus 2 times 0 plus 5 is equal to 0. We'll be left with x plus 5 is equal to 0. And what we'll be left with then is we can plus minus 5 from both sides. We'll be left with x is equal to minus 5. The point then we have here is minus 5, 0. Then we can figure out where it crosses the y-axis. And when it crosses the y-axis, we know that x is equal to 0. So here we'll be left with 0 minus 2y plus 5 is equal to 0, which will give us minus 2y plus 5 is equal to 0. We can take 5 from both sides. So we'll be left with minus 2y is equal to minus 5. Finishing that up here, we get minus 2y is equal to minus 5. We can divide both sides by minus 2. So we're going to get that y is equal to 5 over 2. So the point then we have here is we're going to have 5 over 2, and 5 over 2, as you know, is 2.5. So just highlighting the points that we got there, we got minus 5, 0 and 0, 2.5. Plotting those points then, I'll plot them in green. We have minus 5, 0, so that's going to be here, here. And we also have 0, 2.5, which is going to be here. Then we join these together. You're going to do it with your ruler, and you'll get this here. So we can then find the point of intersection. That's what B says. From your graph, identify the point of intersection of M and N. Now, one thing that we need to do is we need to make sure we label the graphs each time. So the blue one here is M, and the green one here is N. The point of intersection is going to be here, roughly 1, 3. Part C then says, confirm your answer by solving the simultaneous equations. So to do that, I'm going to do it up here on the left hand side. So this is part C. The first thing we do with simultaneous equations is write out the simultaneous equations. What we're going to have is we'll have 3x plus y minus 6 is equal to 0, and x minus 2y plus 5 is equal to 0. Again, we need to get the same number on either the x and the y so we can eliminate it. I'm going to do x again, so we're going to make both of them 3. So the top one is already 3, so I'm going to multiply the bottom line here by 3 to make it 3. What we'll be left with here then is 3x plus y minus 6 is equal to 0, and 3x minus 6y plus 15 is equal to 0. Now, both the lines have 3, however their signs are the same, and we need the signs to be different. So I'm going to multiply the top line by minus 1. What we'll get then is we'll get minus 3x minus y plus 6 is equal to 0, and the bottom line will stay the same, so it will be 3x minus 6y plus 15 is equal to 0. Because the signs are different and the numbers in front of the x are the same, we can eliminate the x. So we get x minus 3x plus 3x will give us 0x, so we can leave that like that. Minus y minus 6 will give us minus 7y, and 6 plus 15 will give us 21. Then we need the y to be on one side and all the numbers to be on the other side, so we're going to minus 21 from both sides. We'll be left with minus 7y is equal to minus 21, and then we need y by itself, so we can divide both sides by minus 7, And finally, we'll be left with that y is equal to 3. Because we know what y is, we can take an equation that we had at the start. So I'm going to take x minus 2y plus 5 is equal to 0. We now know that y is 3, and we can sub in 3 for y here. What we'll be left with then is x minus 2 times 3 plus 5 is equal to 0. This becomes x minus 6 plus 5 is equal to 0. Minus 6 plus 5 is minus 1 is equal to 0. To get the x by itself, we plus 1 to both sides, and we'll be left with x is equal to 1. Now, going back, we know that y is equal to 3. We now know that x is equal to 1. So the point that we're going to get is 1, 3. And we've confirmed that the answer of solving the simultaneous equations is the same answer we got when we graphed the lines and found the point of intersection. So we can see here, I even have it written on the graph. So we have the point 1, 3 and 1, 3. So they're the same. So that's the end of this question. Looking at some of the questions that you're going to be doing. So question 1 here says, use the diagram below to write down the point of intersections of the lines here. So all you need to do is look at the graph and write down the point of intersection. Question 2 says, the diagram shows the lines A, B and C. It says the equations of the lines are given there. It says use the diagram to write down the point of intersection of different scenarios. So that should be perfectly fine as well. You're just reading the point from the graph. Question 3 says using one diagram, sketch the lines and use the sketch to write down the point of intersection. That is the exact same as the example 1 that I did in this video. Question 4, 5 and 6 are the exact same as the first example I did in this video, so they should be hopefully fine if you've watched that. Question 7 says that the sketch of the two lines 2x plus y equals to 6 and x plus y equals to 5 are shown. It says use the sketch to write down the point of intersection of the two lines, and then it says use simultaneous equations to verify your answer. Very, very similar to the last example I did, so example number 4. Question 8 wants you to use simultaneous equations to find the point of intersection of the following lines. That's revising algebra and exactly like the second example I did in this video. And then question 9 wants you to use simultaneous equations to verify that the lines intersect at a certain point. So that question is kind of nice because they give you the answer. So you'll know straight away when you've done the question if you're getting it right or you're getting it wrong. So that's the end of this video. I'm hoping that it makes sense. If you have any questions, please get in contact. But I'm hoping that the questions you're going to do will be easy enough now that you've watched this and seen me do a good few examples.